Hello, and thank you for having us. My name is Andre Dorand. I'm the Water Resources and Project Manager for Triscuit Engineering. And today we would like to present our progress on the Crown Point Business Development Project. So the project overview, the owner specified that we should develop a mixed-use park in Crown Point, Indiana. The park should be divided into 1 acre or larger lots and include a closed-loop drinking water system and an urban road connecting Maryville Road to Summit Street or Indiana Avenue. The design will also include a 40,000 square foot building and water quality best management practices on one of the lots. And now I'd like to hand it over to my transportation engineer.
Hi, I'm Mason Ramsey. I'm the transportation engineer for Triscuit Engineering, and I will be talking to you about the road and intersection alternatives and then evaluating them using a rubric and then the cost analysis. So here's the road alternative 1. It goes from Maryville Road to Indiana Avenue, North Indiana Avenue, avoiding the electric poles through the middle and then connecting at each at a 90-degree angle. And then here is the second alternative. It connects Maryville Road to East Summit Street, also avoiding the power lines, but does cross the gas lines down in the southern portion at East Summit Street. And then here's the rubric that is used to evaluate the two alternatives. It gives each parameter a weighting from 1 to 5, and then also a rating from 1 to 5. The higher being better, and then multiplies them to get a score, and the highest score is the better alternative. So as you can see, the things like the cost and feasibility of the road are weighted way higher than the maintenance and aesthetics. And it shows that alternative 1 is the better alternative, mostly because of the feasibility with connecting to the to North Indiana Avenue, which I like better, and avoiding the gas lines. And then here is the cost analysis for the construction of these two roads. You can see that they're very similar in price, with being similar in distance, and the concrete for the sidewalk costs the most because it's higher level and on each side of the road. So here we're going to evaluate the intersection alternatives. This is the first alternative, and it's just leaving it the same. And this would be the most cost-effective alternative, but it also is the worst in terms of safety and just traffic flow. The second alternative is adding a right turn lane to each of the 4 directions. This helps so that the cars going through the intersection don't have to wait for the right turn to slow down, and also for the right turn doesn't have to wait if it's a red light for the through to stop. They can go on red. And then here's the third alternative. It adds a second through lane for each one, so there's a left turn lane, through lane, and then a through and right turn lane. And then it also continues through the intersection and then goes back down to 1 lane afterwards, except for the north direction, which turns into a left turn lane into the site. Here's the rubric. It does the same thing with weighting and rating each 1 to 5, and it weights things heavily like the cost, the level of service, and the safety, and lower for the maintenance and aesthetics. And you can see that the alternative 1 doesn't do a very good job in terms of traffic flow, which also reduces the safety significantly. But it's still a better option than alternative 2, which also doesn't increase the level of service very well, but would be way more expensive. And then alternative 3 easily wins out, as it meets the level of service C and also costs more, but not too much. And then here's the cost analysis for each intersection. Very similar in terms, obviously the first alternative wouldn't cost anything, as nothing happens to it. But then this is all adding to the cost, and they're similar in terms they don't each add an extra lane, and the second one adds a little bit of lane past the intersection. And now I would like to hand it over to our structural engineer.
Thank you. My name is Christian Robinson, and I am the structural engineer for Triscuit Engineering. Today I'll be going over my different design alternatives as there have been changes and differences made from our previous progress meeting. I will then go over a construction cost analysis for each of those alternatives, and then finally I'll go over an evaluation for the different alternatives. So with the first alternative, again, it is our steel rectangular structure. Some of the changes that have been made are the layout for the actual first floor. So the first floor had a very open space that wasn't being utilized efficiently, so I decided to accommodate for that and add more rooms and add extra space for the sizes of the rooms to accommodate for that lack of utilization of first floor, that extra spacing. Again, the first floor is going to be used as our commercial space, with the second floor being used as our residential space. So some of the accommodations for the first floor are going to be our conference rooms, offices, break rooms for the employees. One thing that I do want to point out is there is a change that I did not make on here for the colors. So for the cyan colored rectangular structures on the corners of the building, those are actually stairwells and not elevator shafts. And these stairs are actually flipped as well, so those are stairwells, or those are elevator shafts, not stairwells. That was changed due to my own personal research finding that if you have elevator shafts in the corners of the building, that causes torsional issues with the structure, as well as having those hollow shafts can provide other structural issues as well. So those are actually flipped and not left as elevators. Again, for our second floor, those are going to be our apartment spaces. Those have also been changed as well. So for those apartment spaces, those have been increased in size. I also want to point out, in my previous presentation, I had each individual room and apartment spaced out, but for this one, rather, I want to just use like a general idea for what I would use as the apartment space. So these aren't exactly, one specific square, one specific section is one apartment, but as we move on with our further development and find which alternative is the best, we'll be able to get a better idea of what exact, spacings and rooms we'll have for the apartments moving forward. The column spacings and beam spacing have been also changed as well. So from my previous presentation, I was advised that I should include the column spaces within the walls rather than having them just in the middle of a hallway or the middle of a room or the middle of any other just open space area. So my best efforts were put forward to ensure that the columns are included in the wall spacings rather than just being in some random hallway area or some random room. I can only imagine when you walk into your room, there's a huge column just in the middle of the way. That's not very efficient at all. For some of the framing assumptions, for the beams, we're going to use W14 to W16. I provided a range to give us like an idea of what beams we could potentially use. For the girder spaces, it's going to be W24 to W36, and for the columns, W14 to W18. For our alternative 2, we have the square steel structure. You'll notice that this alternative is very different from the previous one in the sense that the rooms are symmetrical for both the first and the second floor. This was done to stay true to the inherent nature of the square being symmetrical, so I decided to keep that consistent through the layouts for the different rooms available as well, and also serve as a correction for the open spaces not being utilized. So that addresses both of those previous issues that were had with the previous designs. Again, you're going to have your small office spaces and your large conference room spaces, and then for your apartments, for the second floor, you have your apartments, your fitness center, lounge areas, etc. And then I also did this to keep the column spacings consistent through both the first and second floor as well. So since the rooms are spaced in the same areas, then the columns will also stay true and be spaced in those same consistent areas as well. And again, we use the same similar typical beam, girder, and column assumptions for this design alternative as well. And then for our third alternative, we have the L-shaped structure, the L-steel shaped structure. This has also been changed in as far as the layout goes. I also want to note out that this alternative is different in the sense that it does have public restrooms that are available on both the first and second floor, as well as open office spaces, kind of akin to a library where you have open office for desk chairs, printers, etc. That will also be utilized for those gray open office areas there. Same goes for the lounge space as well. That may actually be like a room, but as of right now, I just want to leave it as like an open lounge space for visitors or other tenants or whatever the case may be. And then for the beams and the columns, again, we just want to ensure that we are keeping our columns inside of the walls rather than having them in the middle of hallways or open spaces. There are some exceptions with this specific alternative, so there are going to be some columns that are unfortunately going to be in open spacings or in open areas, but for the most part, my best efforts were put forward to ensure that all of our columns were kept inside of our walls. And again, our beams, girders, and columns are going to be the same typical assumptions that we used for the previous alternatives. Now moving on to the construction cost, we used RS means, the square foot estimator, to come up with our construction costs for each alternative. One issue that we found with RS means is you are not able to come up with a specific calculation for a mixed-use facility or a multi-purpose building. So in order to accommodate for that, I separated the floors into their own building. So the first floor is going to be one building in a sense, and the second floor is going to be its own building in another sense. And while this does have the issue of including some things such as like excavations, back cuts and backfills, lime stabilization for your building pad, although it does include that cost twice, it is consistent throughout all the alternatives. So while it is considered twice, it still gives us a good idea of what alternative is still going to be cheaper as far as the cost goes. So the first table that we have here is our cost analysis for our first floor, and the second table is the cost analysis for our second floor or second building, and then I decided to combine those costs for a total at the end there. So as you can see, alternative 2 is the cheapest alternative, or cost-efficient alternative. And then for our alternative evaluation, some of the parameters that we decided to go with are the construction costs, the aesthetics, the feasibility, and the environmental impacts. As far as the construction cost goes, I felt that this was the most important factor of them, so this has the highest weighting, and I considered the aesthetics of the building to be not of much as important considered, or compared to the feasibility and the environmental impact, so it does have the lowest rating. So as you can see here, we decided to go with the weight for each one and give each one a satisfactory rating between 1 and 3, with 1 being the worst and 3 being the best. Multiplying those numbers together gives us a score, and then we sum those totals at the end to get our final score. And as you can see from this, alternative 2 does serve as the best alternative with the highest score due to its low construction costs. It's tied with feasibility to the first alternative, and it's tied with environmental impacts across all the different alternatives. And now I'll be handing it off to our environmental engineer.
Hi, I'm Brianna. I'm the environmental engineer here at Triscuit Engineering. And so today I'll take you through a quick recap of my alternatives that I'm going to be analyzing, and then I'm going to go over my cost estimates as well as my rubrics that I designed. So to begin, during my technical design memo, I eliminated 2 alternatives. So my original alternative 1, that is just the one routing along the north side of the design road, has been eliminated due to its inability to provide water to the entire site. And then I also eliminated high-density polyethylene pipe because while it is allowed in the state of Indiana, it's not on the approved materials list for the city of Crown Point. So I did not do a cost estimate for these, and you will not see them in my rubrics either. So my alternatives that used to be labeled 2 and 3 are now 1 and 2 to clear up any confusion there. So my first alternative, this is the north side of the road. So I put the pipeline routing between the back of the curb and the right-of-way, avoiding going underneath the road entirely. I am going underneath the sidewalk at some points, but I thought that was better than going underneath the road in case of maintenance. So this is the south side of that alternative. So I have a branch going down to East Summit Street. The green circles are the fire hydrants. Those are tentative placements as of now, and they are not to scale. It's just that so that you can see where they might be. And so for my second alternative, same concept here, except I have this other segment going up to Maryville Road. And so I'm going to start off by doing my cost estimate for my pipe materials. As you can see, ductile iron pipe is about 10 times more expensive per foot than PVC. So this is going to play a big role in my decision that I make later. So in my matrix, I weighed each parameter 1 to 5, 5 being the most important, and I gave them a score of 1 to 3, 1 being the least desirable, 3 being the most desirable. As you can see, the different materials are pretty similar in the scorings that I gave them, besides the cost, which I weighed the highest because that is the most important factor in my opinion. And so in the end, PVC pipe is what I came out to be my preferred alternative, and that's what I will be continuing with in the next phase. And so for my cost estimate for my pipeline routing, I will say I used PVC pipe for the material cost here because I knew that was going to be my preferred alternative. And so I did a little summary of all of my costs. So that's going to be my material, my trenching, my fire hydrants, and my backfill. Of course, I don't have exact numbers for things like trenching and my fire hydrants and my backfill. So I did a rough estimate of what they would be using RS means. However, these numbers are subject to change probably greatly because as I continue my design, I will have more information. And so for my rubric, same kind of concept, weighted 1 to 5, scored 1 to 3. And in the end, I came out with my second alternative, which has the branch going to Maryville Road as my preferred alternative, just because of the availability of the network to the future lots on the development. And so what am I going to do in the future? So my next steps are to determine the pipe sizing and then also the flow in each of the pipes. I need to perform a hydraulic analysis on my network when I get that information set. And then I also need to beef up my fire hydrant designs. As I said, right now I just have tentative placements. I need to know the sizing of them. I need to do valve selection on them. So there's a few things I need to do going forward. So now I'm going to pass it off to our water resources engineer.
The owner specified that I need to create a flood control volume for the 100-year storm event, achieve 80% total suspended solids and 70% total phosphorus load reduction on a chosen lot, and infiltrate at least 1 inch of water from all impervious surfaces. So what I've been up to for flood prevention, I've been creating these outflow hydrographs using Wind TR55. With these, I'm able to figure out the allowable outflow, flood control volume, and size of the basins. And for water quality, I've had the water quality volume, so I've been preliminary sizing of the BMPs, cost comparison, removal efficiency comparison. So for flood prevention, as we can see here, there are wetlands and flood zones that I'm trying to avoid on this site, including the easement for the electrical. So this creates areas that I can't capture in my detention pond. So we see the outflow that's not caught, and I have to subtract that by my allowable discharge to get my new maximum allowable discharge. And then I can find my design volume from this. And this is a visual representation of how we find the storage volume. So alternative 1 for flood control uses 2 dry detention basins. This is a lower cost alternative, works well in the type C or D soils, and it's safer than the wet detention basins. Cons, it uses a really large surface area. If it's not landscaped, it's unattractive, and it doesn't reduce runoff volume. Alternative 2 uses 2 retention basins. So this has enhanced aesthetics, reduces the risk of outlet clogging because of the sediments filtering out, and then it reduces the flood volume because of infiltration. This has a higher construction cost because of the impermeable liner and the deeper excavation. There's safety concerns because of the standing water, and it requires suitable soils because it uses infiltration. So here we can see our cost analysis for these. The alternative 1 was much better overall. So my rubric, these are weighted from 1 to 10, cost being the most important, and area use being the second most important. As we can see, alternative 1 was the better alternative, mostly based off the cost, maintenance, and safety. And then for water quality alternatives, water quality alternative 1 mainly uses bio-retention processes. So it has a high pollutant removal efficiency, improved aesthetics with the trees along the parking lot, and it's the lowest cost alternative. The cons of this is sediment accumulation, so you have to do routine maintenance. Alternative 2, it has effective water quality treatment and superior dissolved phosphorus removal. Using this perimeter sand filter, it's iron enhanced, so it should remove more dissolved phosphorus. And the cons of this, again, sediment accumulation, and it's a higher construction cost than alternative 1. Alternative 3 uses pervious pavement, a filter strip, and an aggregate pit. The pros of this, it infiltrates a lot of water, there's a low visual impact and effective total suspended solid removal. The cons of this, it requires suitable soils, so this alternative will not work in our soils because the water will not drain within 48 hours. It may cause clogging, so you'd have to vacuum the pervious pit or remove most of the aggregate from the aggregate pit during maintenance, and it's the highest construction cost of all three alternatives. Here we can see our cost estimates for all three, with alternative one being the cheapest. Again, the weight is the same, 0 to 10, and the rating the same, 1 to 5. Cost is the highest weight, followed by phosphorus removal and total suspended solids removal. As we can see, alternative one was our best alternative for this particular project. And my phase 2 work, I need to do geometry grading for both the flood prevention and water quality, and detailed design drawings. Any questions? Yes.
I guess I'll ask you first, Andre. So you mentioned your retention pond is going to infiltrate more, but then you mentioned it has an impermeable barrier. So how?
Geosynthetic liner. I don't think it's impermeable.
Okay.
But it's supposed to infiltrate over here, and then this smaller box is the permanent pond, so the permanent standing water.
Okay.
Yeah.
So we'll infiltrate.
It should.
Okay. And then I don't know if it'll change your selected alternative, but and I don't know if it's allowed in Crown Point, but people have put permeable pavement over C and D type soils. So.
I just found that with the permeable pavement,
Mhm.
it would lead to the water not draining, and it could cause freeze thaw to damage to it. So that's
Yeah.
why I didn't want to
Yeah,
use
okay. You have to have if you have a under drain at some level, then you can prevent that,
It would
but,
improve it.
so, okay.
Hold on.
Well, I have one for Brianna, I guess. So, where are you gonna tie into the existing Crown Point system? Like, you're designing the water distribution system, right? The pipes, like, where's the water gonna come from?
Yes, so if you go back to my schematic drawings, all of the red piping
Uh-huh.
is the city's utilities already.
Okay.
So that's where I'm going to tap in and create that looped system.
Then, do you know an existing pressure there, or how are you gonna?
So I do not have any of that information available to me. I will be just making assumptions. I'll speak to my advisor to make sure that my assumptions make sense. And then I'll do a little bit of research to see what like the average or normal pressure in the area would possibly be.
Okay. Thank
You're done.
Yeah.
My turn. Okay, let's go back to Mason, so start from that end and move across in here. So, I think you mentioned you would have sidewalks on both sides of the street. Why? So, you've been making me pay that $1.4 million for like having 2 sidewalks?
Yeah, that would help for future development on both sides so that people don't have to cross the street to use the sidewalk.
It's a good exercise, so rather than having sidewalks
It's a
on.
safety issue for the most part.
It's a safety issue in there. And then you mentioned that you sort of eliminated one of the alternatives, or at least on the feasibility part of that alternative, you said like you give it a lower score because it crosses either under or over, under the electric power lines or over the pipeline. Why is that an issue?
So it crosses over the gas line, and that just becomes an issue for just working around it. You just rather would avoid it, just to not cause any issues.
I mean, can you explain more? I don't see it. I mean, if that pipeline is 10 feet below the ground surface, why is that an issue for you to have a road?
So it could have stuff to do with just the soil being contaminated, but it also just, you'd rather avoid it if you can, if it's under the road.
And the same because you mentioned because of the electric high voltage, so having a road crossing under a high voltage line, is that an issue?
No, it's just, you have to avoid the existing towers was the issue. So you have to kind of curve the road to make sure your road doesn't come too close to the towers.
And for your second alternative, you sort of put the road somewhere between Thomas and the end of the property in there. Why not aligning the road? If I'm thinking as a traffic engineer in here, I would go directly align it with Thomas Road, so I have one traffic light in this case, rather than have multiple intersections in a short segment of the road in there. So
You're
I did
saying-
not understand the logic about having your road, if you go back to that drawing for alternative two.
That
Yep,
one?
this one in here, so why not aligning with the existing Thomas Road?
So that would just cause a lot of traffic issues if you're gonna wanna bring it into, you're saying to bring it to the intersection?
No, I'm saying you bring it to that road to the south. You see, like
Oh.
where you like the word
I see.
summit,
Yeah. This would just, I mean, that would, you'd have to buy part of that business's right of way, and then also just, I don't know. It just-
no, well, the thing in this case, you're gonna have two traffic signs.
Yeah.
Or whatever,
Yeah.
two intersections to deal with compared to only having one
Yeah,
in there.
no, I see what you're saying, yes.
Okay, Christian, I'm gonna be critical of your visuals in there because I could not follow on the thing. And it's not a standard like engineering practice in there using the so multicolors and the legends in there. It was hard for me to try to follow up where are the columns, where are the beams, which area is what in there. So I just want to make sure that as you move into engineering practice in there, that's not the standard way we do it. It's maybe good for, I don't know, it's like colorful type of presentation, but not sort of an engineering product, I would say. In
Thank you.
there, a standard
I appreciate it.
engineering product in there. And I could not understand the justification of having to break your building, because if it's a mixed use, onto like residential and commercial, given at this stage that you are doing square foot estimate only.
So with with using R as means, when you have to, when you're like putting in your information, it asks you specifically like what type of building or structure that you're utilizing, and that does change like the square footage cost. So if I had done, let's say, residential for both factors, it wouldn't be as accurate had I done like one specifically for like housing and one specifically for like an office space. So in my mind, it made the most sense to separate them so I can get somewhat of an ideal cost for specifically for like the residential aspect, and then one specifically for the commercial / like office aspect. So that's why I separated the two to try to get like a cost for each one.
Okay. Even if the material is the same, like if you
Yeah.
have like a concrete residential, concrete commercial, all of them. I understand if there are different types of materials, like, and sometimes that's the way, it's just you start with more like a steel framed or concrete, and then a lumber or like wood type of structure on top of it, that makes a difference. But if it's like completely like a steel framed like a structure, honestly, I won't even bother divided into two if it's, I'm using the same material on both of them.
Right. I think my thinking was just more so there may be like some factors or some things that were contributed like specifically to the residential aspect that may not be contributed to the office, or vice versa. So in my mind, it just made more sense to be on the cautious side of things. And if I'm looking into the cost consideration specifically for the residential, I should use the residential or the apartment style selection on ours means, and then use the appropriate one specifically for the commercial spaces as well.
Well, and my last question is to Andre in here. I still did not buy sort of your logic of having a retention basin. You have to sell it to me. And so can you just tell me when do you decide to use a detention versus retention ponds or basins?
I think,
So retention basin, as you know, has a permanent pool, so that would settle out more of the pollutants in the water. And so I feel like when that is a huge issue, that's when you would rather use one of those.
Why not like a wet detention basin? What the difference is an outlet structure? Well, I'll tell you why I'm saying that, because if you're using a retention basin, it's gonna be a huge area. You need more land. It's practically you are storing the entire, without the entire flood control water, like a 100-year, 24-hour, with limited infiltration and evaporation, compared to if you have an outlet structure that releases the water actually at a continuous basis or something, or at least during the 72 hours following a storm or something like that. So, well, you're still gonna tell me your justification.
For using the, I'm sorry, can you,
Well, I would say like, I think your selection, except if you justify it to me, is the wrong one. In other words, to select more of a retention, where you can select a wet detention or just a dry detention, and include some of the BMPs somewhere else. If the only reason is for sedimentation of the material, I will just have a frontage wet pool in the detention basin.
I'm still really confused about this question. So I'm using retention ponds, right? And this was my preferred alternative.
Okay.
So I'm using, dry detention ponds. And then you're asking why I'm not using a retention pond.
No, I thought you are using retention, or
No.
did you eliminate that?
I eliminated this. This dry detention alternative 1 was my preferred alternative. That's why I was confused about the question.
No.
My turn? Christian, on one of your slides, you had labeled size 14 beams, and right below it was size 24 girders. What's the difference between a beam and a girder?
So
In the column.
excuse me?
In the column, we all know what a column is, but they're all W sections. Why do you call some of them beams and some of them girders?
Oh, that may have just been a language preference mistake on my part. I was under the impression that the girders were going to be the blue vertical beams that we had, and the beams are the.
Okay, in my world, which is not buildings, beams are W sections. Girders are welded plates that make up what looks like a W section, but they're welded plates. Those are girders. Columns, of course, are columns. So I was just, and it could be in buildings, beams go one way and girders go the other. I don't know. I was not clear.
Do you need an answer?
Hmm?
Do you need an answer?
From you?
Yes. Well, trying to help.
You're an environmental guy?
No, I'm a structural guy also. Well, Christian, girders receive beams, because you may have beams coming across, but the girder can be the major element between columns. That actually, that's the difference in the naming in there. So you can have a girder going across, but you have multiple beams coming, and the load, a point load can come to those girders.
Thank you.
Okay. Mason, similar to what you asked, if we go to the alternative that goes east-west, that,
Yeah.
on the east side, that road seems to intersect at a somewhat short distance away from the road up there. That's called an offset intersection, and those are never a good thing.
Okay.
So I would move that up or down to one of those other roads,
Yeah.
create a four-way intersection. you know, the offsets, when you come out, if you have to make that turn, you know, this traffic is not good.
Yeah, I
So
understand.
line it up
Yeah.
with one of those.
I'll take that into account.
In your cost analysis, how much did intersection costs play? Was that a big deal? You know, when you deciding between alternatives,
This is the cost over here.
you know, what-
No, it's the road at the end.
Then it's up there.
whoa. Did you just have like an intersection cost, or is this one cost more than that one, and, you know, how, was that a big factor in your cost determination?
What do you mean, like,
Like when you're doing a cost estimate for alternatives,
yeah,
you know, you have that, you always have an intersection on this side, so those would be the same, but the cost of this intersection compared to the cost of this intersection, is that a big deal or a deciding factor? Are they the same? There's a lot more traffic on one of those roads than the other, so it's just,
oh, okay. Yeah, so they weren't that much different because of the new traffic on, you're saying that one road will have more and that should change the style of material?
not material, they're just how big it would be, you know, how many lanes there are.
Oh,
and-
they were all, each,
Are they all the same,
had
or-
the same amount of lanes in each direction.
All right. Okay, that's all I had.
So just one general comment, and for other groups as well. We've said this, I think, in the progress presentations, but it's maybe not this slide, maybe a little bit on this slide, but other slides, there's cost estimates of millions of dollars with pennies on them. So, just,
This one's better
Yeah.
than most. Even the $569,500 at this stage, that's 570, maybe 600.
so, yeah. So you just, in the future, just round those up or down.
Round up.
Yeah, so. Anybody else have questions? You guys asked each other questions during progress presentations. Is this like you have a pact now?
All right.
Okay.